Hello everyone, I'm back with another video. So today I'm going to talk about the citric acid cycle, also known as the Krebs cycle or the tricarboxylic acid cycle. So I know this is going to be really daunting for a lot of people. I know it was for me, and learning this cycle has been like, oh my god, there's so many different substrates and enzymes and everything going on at the same time, you know? And so I was like, I'm going to make a video on this so that way you guys will be able to like benefit from the mnemonics that I made. If you stick till the end of the video, I'm going to give you mnemonics to make this a lot easier to memorize and a lot more manageable. Before I begin the video though, I just wanted to say all of my videos are on YouTube. The full videos are on YouTube and they're in different playlists. So I have like general chemistry, organic chemistry, biochemistry, anatomy, biology, etc. So it's going to make it much more, accessible to you guys, so that way you guys can click on the subject that you want to go into and see other videos that I've made. And I just did it to make it easier for you guys. But jumping back to this video, let's tackle it together and go over. So I have in black, I have the substrates. In pink, I have the enzymes. And you can notice that they're enzymes because they end in ASE. What I have in green, like highlighted in green to be more specific, is something that feeds into the citric acid cycle. And what do I mean by that? Well, everything in, as you should know by now, in metabolism and biochemistry, all of the cycles are interconnected somehow. They're not like independent of each other. They overlap. And so, as you know from glycolysis, glycolysis makes pyruvate at the end, actually 2 pyruvates. And so with pyruvate, there are enzymes that can convert into, one is pyruvate carboxylase that converts into oxaloacetate. And the other enzyme is pyruvate dehydrogenase that converts pyruvate into acetyl-CoA. And both oxaloacetate and acetyl-CoA feed and create citrate via citrate synthase. And so then afterwards, it'll feed into the, like, citrate will become isocitrate and so on and so forth. So let's read together what happens. So as I said, oxaloacetate and acetyl-CoA come together, they create citrate via citrate synthase. Afterwards, citrate undergoes isomerization via aconitase and it becomes isocitrate. Then you have isocitrate dehydrogenase. Don't be confused that it's not I period. I use that as an abbreviation so that way it would be able to fit into this picture here. So it's isocitrate dehydrogenase. That after the enzyme works, it's going to produce NADH plus CO2, carbon dioxide, and alpha-ketoglutarate. And this is super important because not everything in the cycle creates NADH, or carbon dioxide. So you need to pay attention to which steps create NADH and carbon dioxide, which is 3 and 4, and only NADH, which is in step 8. So pay attention to that and memorize that because you're probably going to be tested on this. Afterwards, with the alpha-ketoglutarate, you have alpha-ketoglutarate dehydrogenase. And again, that produces NADH plus carbon dioxide, and as well as succinyl-CoA. Succinyl-CoA then has the enzyme succinyl-CoA synthetase. So memorize that. And the first one is synthase, and the fifth one is synthetase. And synthetase makes GTP. So I know it sucks, but you have to memorize that this one makes GTP, not ATP. Now, GTP is a high energy molecule, but it's not the same thing as ATP. So afterwards, it produces succinate. And then succinate has the enzyme succinate dehydrogenase, which then produces fumarate and fat H2. And that's going to be super easy to memorize. Why? Because fumarate begins with an F, fat H2 begins with an F, and so you'll remember that one easily. Afterwards, you're going to have fumarase, which goes to malate, and then malate, you'll have malate dehydrogenase, which again is going to produce NADH and oxaloacetate. So the producing steps per se are 3, 4, 5, 6, and 8. And when I mean producing steps, what I mean is obviously all of them go from an enzyme and make a substrate, but those are the steps that specifically have a NAD or a FAD or a CO2 or a GTP. So those are the steps that you need to really focus on. So it's 3 through 6 and 8. So now that we've gone through all the steps and you've stuck to the end of the video, now I'm going to reveal my secrets to memorizing this whole thing. So for the enzyme specifically, it's going to be on the right, and for the substrates it's on the left. So let's begin with the left side. Cinderella is keto, salad sucks for many, obviously. So Cinderella is citrate. I'm going to highlight as we are going. Citrate, isocitrate, keto, alpha ketoglutarate. And then salad, I know it seems silly, but it has SL. So the L in it makes it succinyl and not succinate. So it's succinyl-CoA. Sucks, then succinate. 4 is fumarate, many, malate, obviously oxaloacetate. And then now let's read the other one. So for the enzymes, sad kids draw funny drawings, or sad kids dream funny dreams. So for this one, the important thing is if you know if it's like a synthase or a dehydrogenase, the name is just, it sticks to it. So like, for example, here you have isocitrate and then you have isocitrate dehydrogenase. So if you know what it is, you just have to stick the name to it. So citrate synthase. So SAD synthase goes with citrate, and then it's aconitase. Then it's a dehydrogenase, SAD, and then kids. Again, you have alpha ketoglutarate, so the keto dehydrogenase. That's how I remember it. Kids. Again, you have your S, so it's going to be a synthase. And then draw, dehydrogenase, funny, fumarase, drawings, dehydrogenase. So this tells you what you have. If you have a synthase, if you have a dehydrogenase, or if you just have and the only one like fumarase or aconitase, they're separate. So it just reminds you where you have a dehydrogenase. Because like I said, if you know it's a dehydrogenase, you're like, oh, okay, that's isocitrate dehydrogenase. Oh, that's alpha keto dehydrogenase. Oh, okay, then that's the synthetase that we talked about. That is going to produce the GTP. Oh, again, you have a dehydrogenase, and so on and so forth. It's just to kind of keep you present, like which step happens. If you enjoyed this video, it takes time to make these videos, so please follow me here and on YouTube, and give me feedback if you have any other subjects, or like we're specifically in this subject, any pathways you want me to go over. And again, it doesn't have to just be biochemistry. If you have questions on organic chemistry or general chemistry, etc., just let me know. Again, follow me here on YouTube, and like and share, and thanks again for watching.